One-way ANOVA and two-way ANOVA are powerful statistical tools that help us understand differences between groups. Imagine you're testing 3 different diets to see which one leads to the most weight loss. One-way ANOVA lets you compare these 3 groups directly. It tells you if at least one diet is significantly different from the others. Now let's spice things up with two-way ANOVA. This method allows us to explore 2 factors simultaneously, like diet and exercise. Here we can see not just the main effects of each factor, but also how they interact. Maybe a high-protein diet works wonders, but only when paired with regular workouts. In essence, one-way ANOVA is your go-to for single-factor comparisons, while two-way ANOVA dives deeper, revealing the interplay between multiple factors. Both are essential for making informed decisions based on data, transforming raw numbers into actionable insights. Welcome to Chandra Shekher Research Academy of Business Studies. Today, we will explore one of the most important statistical techniques for decision-making: analysis of variance, or simply ANOVA. We'll cover 2 types of ANOVA, one-way and two-way, and simplify the formulae for easy understanding. ANOVA, a statistical method to compare means of groups. ANOVA helps us determine whether the means of 3 or more groups are significantly different. It is especially useful when dealing with categorical independent variables and a continuous dependent variable. Comparing sales across regions for one-way and sales across regions and time periods for two-way ANOVA. One-way ANOVA is used when we have 1 categorical independent variable and 1 continuous dependent variable. For instance, comparing the sales performance of 3 sales teams. Formula for one-way ANOVA: F(NAR) between group variance divided by within group variance. Step-by-step breakdown. Calculate the total sum of squares, SST. SST cars sum of each data point minus overall mean, squared, where each data point hires individual observation and overall mean, average of all observations. Calculate the between group sum of squares, SSB. SSB, sum of group size times group mean minus overall mean, squared, where group mean, average of observations in each group and group size, number of observations in each group. Calculate the within group sum of squares, SSW. SSW, sum of each data point minus its group mean, squared. Find the F ratio, F MSB divided by MSW, where MSB, SSB divided by between group degrees of freedom, and MSW, SSW divided by within group degrees of freedom. Decision rule. If F a critical value from the F distribution table, we reject the null hypothesis. Two-way ANOVA is used when we have 2 independent variables and 1 dependent variable. For example, studying the effect of region and promotion type on sales performance. Formula for two-way ANOVA: total sum of squares. Sum of squares for factor 1, plus sum of squares for factor 2, plus sum of squares for interaction, plus within group sum of squares. Step-by-step breakdown. Calculate total sum of squares, SST, same as in one-way ANOVA. Partition SSB into factors. Sum of squares for factor 1, SSB1. Sum of number of observations in group times. Factor A mean minus overall mean squared, where factor A mean hakas mean for first factor. Sum of squares for factor 2, SSB2. Sum of number of observations in group times. Factor B mean minus overall mean squared, where factor B mean chakas mean for second factor. Interaction. Sum of squares, SS interaction. After sum of cell mean minus factor A mean minus factor B mean plus overall mean squared. Calculate the F ratios. For factor A, FA, mean square A divided by mean square within. For factor B, FB, mean square B divided by mean square within. For interaction, F, interaction, mean square interaction divided by mean square within. Decision rule: check the significance of factor A, factor B, and interaction. Reject the null hypothesis if F has critical value. Real-life examples such as effect of fertilizers on crop yield or impact of training and experience on performance. ANOVA is powerful for decision-making in business, agriculture, healthcare, and more. Remember, one-way ANOVA compares one factor across groups, while two-way ANOVA examines two factors and their interaction. Thank you for watching. Don't forget to like, share, and subscribe to Chandra Shekher Research Academy of Business Studies. See you in the next video.